Okay, we're back again. Last time we did a little bit of work on trying to measure what the problem is with the frame rate being pretty slow, and we attempted a couple of things to make it better that, as far as I recall, didn't really make a difference. So what we're going to focus on is trying to bring this down. It's about half of our budget per second. So if we're aiming for 25 frames a second, more specifically, if that's our target, and it doesn't have to be, but it seems like a reasonable thing to aim for. That's, this is basically 40 milliseconds. This is a frame, essentially. And this window is the current one, right? So it seems like roughly this. Well, I don't know what the relationship is between these two are, but this is the recording window, which is much smaller, so it's much quicker. And this is the entire current terminal window, which is much slower, and eats up basically our entire budget for rendering a frame. And that might be okay, might be able to live with that if we didn't also spend another 40-ish milliseconds rendering a frame instead of, essentially by converting it to wavy. So we need to do something about that. The first thing I'm going to do, just to get an idea of how just to get an idea if this is worth looking into, is I'm going to replace this YAV conversion by making it inline. What's the best way of doing that? Because the thing is, even if we don't have a frame to render into, we still want to be rendering the window preview, which means we are going to have to copy data from that to somewhere else, unless we can make a frame that is backed by the data, but I don't think that's supported. I think it gets copied out eventually by FFmpeg. I don't think what I have in mind is supported, especially since codecs can buffer over across multiple frames. It'd actually be kind of nice if we could just make the codec own the... No, because if we made the codec own the frame, it would own the underlying buffer, so we'd have to do a copy anyway. So that's a no-go. So we're going to need a copy into the frame. I guess the question is, how do we want to do that? The alternative is we use the BRGA 0 or whatever it is codec for X264, since we could really just basically feed it this data. Though I can't remember if that's a planar format. I don't think so. Because my vague recollection is it essentially matches exactly the input format from X. So that's another cheap option I would like to try. I don't know which of these is the best to do. I think the first thing I'm going to try is inlining the conversion. And then we're going to have to put it somewhere. So let's start with this. Right, and so the video buffers are just one big stream. They're not planar. think what I'm gonna do at the moment because the thing is I really only need one video buffer per screen, which means one video buffer at the moment. I think I'm gonna hack something together right now. So we'll go frame, and then we'll have unsigned sharp pointer for chrominant luminance, and then our two chrominance channels. And I think what we're gonna do yeah, so we'll go X context, and then how does this work? We want to skip over y times width sure, I can reuse that. And this is planar, so we don't need depth. And then I think we just add on the x coordinate. Yeah. And then we do UV. So we do UV. And then we can make the frame just a copy. So this shouldn't speed up like at all, these numbers, because I think they're just measuring blending. They're not measuring the conversion. But we can measure that. Yeah, it's just measuring blending. So here, what we want to do is we want to go memcopy VO frame data. And then we want to copy from X context. We shouldn't be doing it this way, but we're going to hack it together. No, that's a point already. And then because we have full, I also think that's a pointer, not a, because we have full, there's no loss, there's no, I don't know what you would call that. This is your 444 is basically what I'm trying to say. So we just do width time height for all of them and just do a mem copy. Yeah, like that, exactly, cool. And we're doing an I times line size. Yeah, I guess that's better, but we're hacking it together, so we'll get rid of all this. I just want to see how it performs. The other thing we need to do is allocate. Where do I get the geometry? Oh, it's in the screen. Okay. Let's go down after we initialize all the screens. And let's malloc height in pixels times And then this should be width in pixels. No, wrong. Incorrect. Where did I put it? I didn't even put it in here. Wow. Because I want this to be like that for, no. Like that. Right? I think that's right. Alright, and so now we need to go fix up what we did here. Because that doesn't need to be there. And this doesn't need to be there. Alright. I think that doubles. I do not think they're doubles. I think they're just unsigned chars. Oh. I don't know if this is the same order. If the X11 frame has the same order as the FFmpeg frame. Previous definition of wires here. Yeah, sure is. Wanting shift count of greater than or equal to width, yeah. Unsigned longs? That seems highly unlikely to be necessary. Yeah, that's fine. Alright. Okay. So the blending should take the same amount of time. And that seems to be about right. It doesn't look like we really... There are some slow frames here. I don't know. Maybe we added a little bit of variance and maybe slightly shifted up how long it took to being closer to 40 milliseconds. Yeah, possibly both those things happened. It's hard to tell just by eyeballing it. But it looks like we may have shifted up how long it takes and added a little bit more variance, at least in the upper ends of how long it took. So what I want to do is I want to get a sense of how long a frame takes now. Firstly, I want to know if it works. Okay.